welcome to today's webinar on 7 ways to dramatically cut cloud costs. Happy to have everybody here today. A bit of quick introduction. I'm Steve Reed-Pittman, Director of Enterprise Architecture and Engineering here at Envisor. I'm hosting today and I'll be chatting a little bit with Keith. But our main presenter today will be Keith Knowles. Keith is a serial entrepreneur with extensive cloud experience. He's a FinOps certified practitioner and he leads the Envisor team here. So Keith will be doing most of the presenting today. And with that, I'm going to turn it over to Keith for the moment. I'll jump back in here in a few slides, but Keith, why don't you go ahead and take it away?
Will do. Thank you, Steve. And hopefully everybody's here for the right reason and is well aware of what we're about to kick off and talk about, specifically rise of the cloud economy. And I know we've all pretty much jumped on the bandwagon, and we've seen some tremendous growth in the cloud economy. It's been a wild ride, right? It's far exceeded everybody's expectations as far as, especially if you work for Microsoft, Google, or AWS and track the earnings. You can see just the amount of spend has gone through the roof. For those of us that are more on the consumption side and paying those folks, a lot of us have seen some challenges with that. A lot of us have jumped on the cloud. We've seen the costs kind of go up a little bit higher than a lot of us expected. We're seeing the industry, it's not a day goes by, I think, when I read something in the press about a billing surprise or somebody's spent too much on the cloud, or far more than they expected to spend on the cloud. So when you start looking at this in depth, everybody we talk to virtually is like, well, yeah, I'd really like to cut my cloud costs. And Gartner did a study a while back and basically did this little statement that, roughly 80% of organizations will overshoot their budgets for cloud spend. And we're talking primarily about traditional, cloud IaaS, PaaS type things, not your Salesforce bill, or not your applications that are running in the cloud, but really folks that are running applications in the cloud and they're managing them as opposed to using a data center. Makes a lot of sense to do that, to move to the cloud, but again, without closely managing it, your expenses can get wildly out of control. So appreciate everybody taking the time to join us today. And what we're going to end up doing here is really talking about how you can save money on your cloud. And if you're not taking advantage of any of these things that we're going to talk about today, they're kind of in order of ease to deploy and payback. Although there's some things towards the end we're going to talk about, specifically like moving to cloud native, that really can have huge payback. But the time and effort that goes into that is much higher than some of the first things we're going to talk about. So we're going to go through each one of these, some of them pretty quickly, some of them are pretty easy topics and pretty quick. Some will go into more depth with some better examples, and hopefully you'll leave this webinar with some thoughts on how you can apply some of these policies and initiatives at home. So we're going to jump in here with a quick poll. I'm actually going to hand this over to Steve, but we're going to and then get right into the 7 ways you can dramatically cut costs from your cloud.
Thanks, Keith. So I'm going to go ahead and launch the poll here. The question for this first poll, and we've got a conflict here. Hang on a second. The polls are mislabeled. Apologies, gang. All right. So Keith, can you just confirm for me? Do you you optimize your cloud costs on the poll screen? Yes, I see answers coming in. All right. So the question is, how do you optimize your cloud costs today? Do you review your cloud bill monthly? Do you use cloud native and/or third-party tools and optimize based on that information? Do you have a cloud optimization team? Do you use an MSP or a service to optimize your cloud? Do you simply not optimize at all, or do you not know? We got a number of answers coming in here. I'm just going to go ahead and leave this open for a little bit. It looks like a lot of you do review your cloud bills monthly. That's a great approach. Of course, as you also probably know, reviewing your cloud bill can be a bit of a mind-numbing experience if you try to interpret some of the level of detail that's often in those bills. But certainly knowing the overall spend from your cloud bill each month is really, really valuable. Looks like about a quarter of you don't know how you optimize your cloud costs. So we're here to help with some ideas around that. And about a quarter of you just don't do any optimization. So also Keith will have some tips to help out with that. I'm going to go ahead and stop the poll now, and Keith, I'll let you take it away again.
All right, thank you. Thank you. So that is really interesting. I mean, it's for those of you that have looked at your cloud bill, it's always an interesting thing, right? You bring up the cloud bill, you have the invoice that comes in once a month. It has the details that are really large buckets, and I kind of liken the exercise of reviewing the cloud bill to looking at my credit card statement from a month or two ago and trying to figure out, oh, there's a restaurant bill on there for a few $100s, and I'm trying to figure out who did I even go to that restaurant with, and it doesn't give me any details as far as what it is. Um, and so it's really difficult to do that retrospective and understand that cloud bill a month after the events or 2 months after the events, and then to kind of go the opposite extreme. If you to use AWS terminology, you get into the curve file, and it's all of a sudden you have all these details that you can't comprehend by looking at the curve file. You then have to bring it into some sort of tooling to be able to look at it and view it, and it's really fine grained at that point in time, and it needs to be organized. And without some basics that we're going to talk about here today, it's near impossible to do anything with that unless you then sign up for some additional tooling. I will say, and I probably should preface this a little bit sooner, we are talking about, and a lot of the examples we're going to be talking about today are AWS specific. However, they can be applied to AWS, they can be applied to Azure, as well as Google Cloud. So for those of you that are in the, and then obviously there's a whole host of smaller clouds providers out there that many of them use the same types of schemes, but really everything that we're going to talk about here today is applicable to Azure, AWS, and Google. So I'll try to interject some examples of those as we get into this. And so as we get going forward, and I'm going to start into the 7 ways at this point in time. And this first one's a mouthful, right? It's maximize commitment-based discount savings. And I'll get more into what that is on the next slide. But if you look at what this is, the effort of this is relatively low. The risk of it's pretty low, actually, unless you factor in the financial aspects of that, and that gives it to a higher risk category, kind of that medium category. And I'll talk more about why that risk is there in a moment. And then from a potential savings, it's huge. It's absolutely probably the biggest bang for the buck. So the for your effort, jumping in and implementing, if you're not using commitment-based discounts today, that's going to be your single biggest savings in your environment. So moving to the next slide here. And so the types of commitment-based discounts that there are. So when you look at what's out there, so there's savings plans, which are available both on AWS and Azure. There's reserved instances, which are covered by AWS, Azure, and Google. Google does call them CUDs, or committed use discounts, but very similar. All of these are very similar to one another as far as the way they implement them. They all have nuances. Google's probably the biggest nuance because of the way they do their account structure. Both AWS and Azure use kind of an account hierarchy to dictate what resources can be covered under these savings plans, or I'm sorry, under the reserved instances in the case of Google. But Google uses projects, which is something you need to be aware of your project structure. Otherwise, if you do purchase and engage in one of these discounts, you end up in a scenario where if you bring it too low in the project structure, it will only apply to that structure, not be saved across your organization. So, and then the last one here, and I'll talk more about these as we go on, is spot instances, and taking advantage of spots is a huge opportunity for companies that have applications that can be used in spot. So, and I'm going to kind of recap kind of the savings opportunities in a moment, but when you talk about spot instances, they are excess capacity. It's not currently being used within a cloud service provider or CSP. So that instance, that spot instance, can be sold at a discount as much as 90% off pricing. Sounds like too good to be true. Well, it is in some instances, right? So the reason it is too good to be true is because the pricing is 100% an economic model in its pure sense, where it's supply and demand based, and as soon as that capacity needs to go to somebody higher up on this list that has a savings plan or reserved instance or is buying something at the retail rate of an on-demand price, the CSP will terminate that resource and bring it back, put it back in the pool, making it available to other customers that are paying a premium or a higher or have a reservation or savings plan. That termination notice, if you're not familiar with it, it's like 30 seconds for a 30-second notice on Azure, I believe, and it's 2 minutes on AWS. So if you're running something, you think, hey, you know what, I'm going to run my ETL jobs on a spot instance and I'm going to save 90%. There's no guarantee it's going to complete. It might depend on the time of day, but there's just no guarantee. So running spot instances, usually for workloads that aren't time dependent and can be broken up, and usually it takes some sort of a architecture or that's been architected to leverage that spot instance. So I'm not going to spend a whole lot of more time on spot instances. I'm going to jump back into savings plans and talk a little bit more about those, and then reserved instances, and we'll go from there. So savings plans. So first off, all these are kind of interesting concepts with a lot of nuances to them, right? So savings plans are commitment to a specific rate of spend per hour at a discounted price. These discounts can be pretty substantial, right? So they can be upwards of 60%, depending if you're making a 1 or 3 year type of commitment on that. But it's for a commitment, and the savings plan is spend per hour, and they do things in certain ways. And I'll talk about AWS. For the savings plans are really focused in on, like, I want to buy an EC2 instant savings plan. The neat thing about that is it allows me to apply that to multiple EC2 types of items versus a reserved instance, which similar discount, but it's now committing to a resource burn rate per hour. So I'm committing to a T3 server, pick your size. I'm committing to that, and I'm going to use that server. Basically, I'm committing to use it 24 hours a day, and I'm going to get billed for 24 hours a day, 365 days. Or if it's 3 years, I'm going to be billed 24 hours a day for 3 years for that instance, whether I use it or not. So but it's very resource specific. There's some neat things about what they call instance size flexibility. So I could buy, as an example, I could put a reservation on 10 T3 nanos. I can then extrapolate that out to those 10 T3 nanos will cover X number of a larger size. So the size does allow me to scale it, unless there's a Windows type operating system on that server, but allows me a lot of flexibility to apply that. However, it is going to be very locked in at that family, so to speak. So the savings plan is much more flexible. Savings plans are newer. They're easier in most cases. They're easier to implement. One key difference between a savings plan and a reserved instance that I'll note is the savings plan, again, I'm buy that savings plan, I'm locked in for that term that I buy it for. The reserved instance, I'm still locked in, although there's convertible reserved instances that allow me to change to different instance families or operating systems. But I don't really need that so much if I'm buying a savings plan. But the one key thing is, if I'm expecting my business to be highly variable, potentially going down, as maybe I'm shutting off a division or something like that, the reserved instance is sellable on the marketplace. Now, you're going to pay a commission to sell that. You're going to lose some money on it, but you can get out of it by selling it on the marketplace. So that's one key difference between savings plans and a reserved instance. So with that, I'm going to go ahead.
Keith, actually, before we move on, there's a question coming in about choosing between savings plans and reserved instances. So, like, if a customer is just getting started with looking at ways to optimize their cloud environment, it seems like saving plans offer more flexibility. Is that a fair answer?
It's 100% true.
Or
Yes.
does it depend?
It's
like, would you recommend savings plans over reserved instances? I guess is the
for the most part, we would recommend savings plans over reserved instances. Now, there's certain types of classes of servers that or VMs that aren't necessarily available as a savings plan. As example, probably one of the most notable one is AWS with their RDS. Is not available as a savings plan. But if there's a savings plan available, we would almost always, that would be our go-to, is that savings plan versus a reserved instance. Again, there are potentially some nuances that might say look at a reserved instance, but for the most part, savings plans would be our number one recommendation here.
Great. And I think I heard you say earlier that the amount of discount is roughly the same in both cases. Like they're pretty close.
It's absolutely
Or
the
does that
same,
vary?
and we're going to go. We have a slide on that momentarily. We do have another poll. Just kind of curious, how many of you are out there actually using savings plans or reserved instances or both? So always
Yeah. So
interested
here
in
we
hearing some
go.
feedback on that. So
Yep. So the poll is up. So this is about using savings plans versus reserved instances, not reversed instances. So far we don't have anybody using RIs or SPs. Oh, wait a minute. No, we've got
we
a
do,
number of people using both.
we do, and
Some
just
using
a
neither.
little history as this poll's going on, right? So the first discount program that AWS came out with was the reserved instance. There's quite a lot of tooling around reserved instances that's been built up, and there are some companies out there that will resell and trade those reserved instances, and that's kind of their primary business. So you will run into companies that are very much reserved instance focused, and that's their main play is they help you get, optimize your reserved instances. Savings plans have been out for a little over 2 years now. We do see savings plans, and kind of our company position on savings plans is they are kind of the wave of the future, so to speak. And we do see the adoption rate of savings plans just increasing. And there's a lot of interesting things about them. Just again, they're a lot more flexible. There's a couple different types of savings plans that are available too. So if you have like a global operation, the savings plans can be applied globally. So if you have demand that maybe in a certain region is highly variable, but it's during business hours in that region, then you have an organization or entity on the other side of the globe or something that can use that demand. A savings plan allows you a lot more flexibility because it can be applied globally. Reserved instances are very regional and very specific. So you kind of look at the way these things work. The reserved instances are really focused as far as, and very rigid as far as when you're making a decision and trying to analyze and figure out what do I even want to buy. They're much more complicated.
Right. And I went ahead and wrapped up the poll and shared the results there. So I'll let you go ahead and move on to the next slide, Keith.
Okay. All right. So I did promise that we were going to go ahead and share some of the pricing, right? Just an example. So this is, and I, most of the examples here are AWS. You will find similar types of discounts on Azure and with Google's with their CUDs. But the on-demand pricing, this is AWS T4 large, T4G extra large US West. As for those of you, I think are probably everybody on the call is probably well aware that the regions dictate the pricing to some extent. On-demand pricing for this is $116 per month, $117 per month is the effective cost, right? There's no discount. That's rack rate. I'm going in and buying an on-demand instance right now. So if I want to go ahead and go to the next, make an actual commitment for this and go into buy a savings plan for this for 1 year, and so I buy a 1 year savings plan. This case it's prepaid for 1 year. My effective monthly cost goes down to $69 for that same server. So if I have and the interesting thing again is these things can be applied to any server that's running, right? So it's not just a specific server; it can be applied to any server that it's running. And I'm looking at a 41% discount here. Now I go to a 3 year commitment, and my price goes down to, 62% is my discount on this. So I've got, basically $43 per month. What's really telling here, and this, I don't know, Steve, if this jumped out at you, but when I first look at this, I'm like, okay, my total cost for 1 year for running an on-demand is $1,400. Total cost for 3 years is under $1,600 for that same server. So that's just really kind of brings things perspective to me. And so I find it really interesting. Now, some of you may be saying, okay, so wait a minute, I moved to the cloud because I wanted the agile nature of it. I moved to the cloud because I wanted to be able to turn things on and off. I wanted the on-demand aspect of this. And now you're telling me I need to make a commitment. And that's kind of like, doesn't compute, right? Well, you're not going to make a commitment for 100% of your spend more than likely. You are going to, and we do recommend layering these savings plans or reservations on so that you can buy and basically cover your demand and make it, and not necessarily 100% of all of your usage will be covered by these things, but we do recommend that you layer these things on. And if you have a highly variable type of a business, you could certainly layer something in, and we can help figure out what the break point of some of the stuff is. So it's pretty interesting from a strategy perspective.
Yeah, and to your point, Keith, like it's super valuable using those savings plans. I mean, the potential cost savings is tremendous. And in the case where what some of your resource needs are, which a lot of us are in organizations where there are certain resources that are predictably going to be needed, and you can safely commit to a savings plan and really save a significant amount of money.
Yeah, absolutely. And I did want to add one comment here, because I did use kind of the extreme examples of if I go to a prepay. And so I'm prepaying 3 years out. Now, if I decided I wanted to make a 1 year commitment and pay monthly, I'm still looking at a 37% savings. If I want to do a 3 year commitment and pay monthly, it's a 57% savings. Still massive savings off of the on-demand pricing. Okay. So with this, these things can be a little bit mind-numbing when you try to figure out, okay, so now you tell me to go buy these things and sign up for them. Where do I even get started, right? So there's tooling that helps you visualize the opportunities. The cloud providers have some recommendation engines that will help you go in there and say, well, what do I need to cover my demand? They're typically going to do a look back in a period of time and then forecast based on that look back to tell you what you should sign up for. You still need to apply what you know about your business and your business needs. And if you have technical initiatives underway that you want to factor in, we feel having some tools that help you visualize what that looks like, being able to look at the various things such as your reservations and your coverage levels are really helpful. Whereas a lot of the tools that come from AWS, Azure will just spit out, hey, buy 4 of these, and buy, of course, buy 4 of them for 3 years, which can be a little intimidating when you first want to go push that button, because again, you're making a commitment. You're going to pay for that whether you need it or not. But in most cases, most companies see their cloud business grow. Or their cloud consumption, I should say, grow as their business grows. And so usually decreasing usage is not going to be dramatic unless you have a structural change going on or an architectural change. Then you're going to see some of those types of things come into play, and you want to factor those in. That comes back to our recommendation that you layer or add savings plans or reserved instances in layers or tranches that allow you to slowly build up and then react. Or you could say, we want to cover, instead of covering 100% of the available resources or 80%, I want to just cover 50%. But you still want to use these things. And the beauty, if you have something architectural going on, buying something like a savings plan gives you a lot of flexibility to use that or apply it to other compute types of capabilities. So, all right. Moving forward, eliminating unused resources. This is a pretty low effort in most cases, relatively low risk. The savings potential, 5 to 10%. All this all of these things are going to be, your mileage may vary, right? So everything depends on what your cloud hygiene's like currently. So if you are managing resources and basically eliminating unused resources on a regular basis, you end up in a scenario where your cloud savings, there's probably, in your fine tune, there's probably not going to be a lot for you to save in this pace. But if you aren't, and you haven't done an assessment, we typically, when we talk to folks, it's pretty mind blowing how much they have as far as things such as unattached storage, age snapshots that have been sitting around for years, things, unused IP addresses, those types of things really jump out, right? So, and then we'll often find unused servers that are just running idle. And those are potentially a security risk by, you've got something sitting around that's not being managed, it's idle, and it's been sitting there running for the last 2 years at 25 cents an hour, which is insidious, right? These things just add up at 24 by 7 by 365. Next thing you know, the dollars add up very quickly. Um, so there's a really interesting opportunity here to look at these different types of things. There's a lot of tooling out there that'll help you assess this, understand what's been unattached, what's not used, help you find these idle types of resources. They do require a little bit of homework though, right? So I say the risk is low, but it's not zero. So when I say it's low, you have a scenario where I find something that's unused or has been sitting around for a while. I need to try to track down the owner to be able to make sure that it's truly is unused. And there's some other options potentially around right sizing that you might want to look at in that case. Especially if it's a storage scenario where you might be able to move something to archive as opposed to just shutting it off. You just don't want to shut things off because they look like they're idle, but you do want to do the analysis and make sure you're buying from your team. Okay. Moving forward, the next one, turn the lights off, which people look at my slide deck and say, Keith, this isn't the same as what you just told me. Turn the lights off. And it's a little bit different, and it's a little, trying to have a little fun here with the wording. This is low effort, low risk, potentially some really big savings for folks. And this is more like automate things, right? So if you have development environments that are only being used a certain portion of the day, turn them off, and then automate the turning them off and restarting them. So you can get those on and off depending on when they're used. You can scale things up and down based on demand. There are some caveats to this. Things such as when you scale things up and down, if they're not cloud native, a lot of things don't respond well to that. So if it is a cloud native app or cloud native, like a Azure database, you can scale it up. You scale up all to your heart's content, right? And you don't affect anything. If you are running SQL on an Azure VM and you scale it up or scale it down, you have to restart that system. So it's not going to recognize the changes to system size, and it's going to cause problems. So you do need to be aware of what you're scaling up or scaling down, but we do have a lot of folks that we end up helping them automate and turn things on and off. This is a little bit of a graphic from a company that is automating has automated scaling down a number of their environments when they're not in use. This ended up being in those servers that were affected, over a 70% decrease in cost for these folks. These are point and click types of things with the right tooling. So basically scheduling an event, you point click. I know we use this quite extensively within the Centurus proper environment as far as scaling things up and down. I know, Steve, I think you've used this a fair amount as well.
Yeah, actually, there's a really specific case that we encountered, which is that we have an Azure database that was running at a certain kind of constant high resource level 24 hours a day, but really we didn't need that much compute power behind that database, except when the nightly ETL was running for that database. So we really needed the full power of the database about 15, 20 minutes a day, but we were paying for it 24 hours a day, when for the rest of the time, besides that little window, we just really needed to do queries, which are not particularly compute intensive. And so we were able to switch to scaling that database up and down. So it literally scales up just during the window when we need to run that really compute intensive process. And the rest of the day, we can run it scaled way down so we can service queries as they come in, but without incurring that cost. So that's just one example of ways you can use scaling to really reduce your overall spend.
Yeah, it's interesting thing about that too, that scaling is when you take a scenario like that where you typically would have sized that server at potentially, let's say, a small, and it would take 2 hours to complete that ETL or whatever that job process was, may take 2 hours. Now with scaling, you turn it up to a much larger size for a very short amount of time. You crush that data out in 15 minutes, and then you scale it back down. It opens up and frees up additional windows to do other things with that data, with the servers downstream, et cetera. So it kind of changes that paradigm too, from picking a server size that's static to being able to pick something that's appropriate for the job at that point in time. Okay, moving forward to right sizing, and this is exactly what it sounds like. If is really looking at resources and making sure that they're appropriately sized, right? So the effort's medium here. The risk is relatively low. Potential savings 5 to 10%. Relatively low risk from the perspective of you are going to need to make sure that if you're doing this analysis, and then you need to make sure you're involving your devs and developers and engineers and make sure that right sizing something is the right thing to do. And you also need to make sure that when you're looking at your tooling, and a lot of the tooling that you'll see from the cloud providers, that's the cloud native types of tooling and stuff, will tell you that something is perhaps underutilized on a CPU, yet it's over or maxed out on IOPS or other aspects of that thing. So you need to make sure you're looking at a complete picture of this. And so if you're using tooling that doesn't have a broad enough picture, you definitely need to partner with your engineering team before you make a move, because you may find out that in fact, no, we need that size because it's memory bound, it's IOPS bound, etc. And so you are looking for a couple things out. You're looking at both opportunities that are for things that are undersized, as well as under provision. So you are looking for both things. And then there's also different opportunities. There's a lot of stuff is compute related, but then storage also, there's a concept of right sizing with storage. And from that perspective, you're looking at, am I using the proper class of storage for a specific data need, right? So we talked about snapshots, we talked about some of these other things earlier, and eliminating unused things. There's also a potential for savings by making sure that you've moved things to the right level of storage. So you look at AWS and their standard pricing. And these numbers I find kind of underwhelming when I look at them, because it's a 0.2 cents per gigabyte. Doesn't sound like a whole lot, but as I think everybody's aware, this stuff adds up very quickly. You start scaling it out across your organization, adds up very quickly. But you go from something here that's 2 cents. This is your data that's accessed frequently, right? But if you're using that to store things like that don't need to be readily available, it could be archived. You could potentially take that from point, from 2 cents per gigabyte, you could take that to 0.4 cents per gigabyte. So you're looking at a pretty big change in costs there, right? And again, the numbers, when you first look at them, like, well, who cares, right? It's only pennies. It's a small amount. But again, when you start doing the math and you start multiplying this out by what ends up being in most organizations, terabytes of information, and the 24/7 aspect by 365, next thing you know, the numbers are pretty big. We just worked with a client, kind of a mid-size company, the other day, $100,000 a month in cloud spend, and just by moving a lot of the stuff that could be archived, moving to archive was $3,000 a month in savings, actually a little bit higher than 3,000 a month in savings. Again, So it's 36,000 a year in savings by making those changes. They're very easy to implement these things. These are almost zero risk as well. But you do need to make sure that you're working, you find the owners and work with those folks to make those things. So pretty big opportunity for savings here. Tremendous, actually, anyway. So the next one, anomaly detection. So Steve, I think you are probably best to talk about this one.
Ah, yes, anomaly detection. So, one of the sort of initiating factors for Envisor a few years ago was that we had an internal sort of excessive cloud spend that was unexpected. And we didn't discover that we were running extra resources until the end of the month, of course, when the bill shows up. Uh, and so I got a call asking, why is our bill, several times higher than normal this month? It turned out inadvertently we had left on a server that wasn't needed, that typically ran very rarely. So there are a few ways to deal with anomaly detection. One is there are some tools available from the vendors, and at that time, I actually implemented the AWS anomaly detection, which, to be honest, was terrible originally. It's gotten much better, but it really was not helpful in terms of identifying true anomalies. But today, it actually does a pretty good job of that. Internally, we actually use our own tool now, which gives me daily cost reports, which is fantastic. And so I can always know, you know, up to the day at the very least, and often even up to a subset of the day, whether something is running that maybe shouldn't be. And so having the ability to identify and recognize when something is out of the ordinary sooner rather than later also makes a huge difference in terms of cost savings. It's much better to discover today that we have a machine running that shouldn't be running rather than finding out when we get the cloud bill a few weeks from now and it's been running for 3 weeks instead of one day. So anomaly detection is a big help.
It absolutely, and it's if you noticed on the previous slide here, we kind of shifted from a percentage savings to high, right? It's really a cost avoidance in this scenario, and it's really being able to quickly identify those costs before they build up and become a massive expense. We've also have stories with our clients that folks have used the anomaly detection, and they've had alerts trigger really odd usage patterns. They jump on it and they find out that they've actually been hacked. And so the anomaly detection also helps identify those types of things as well. So it's a pretty powerful thing. The big thing about it, right, is you can set different thresholds. The tools are getting better every day, as Steve mentioned, right? And we're going from basically very simple criteria-based things to looking for usage patterns to applying ML to these types of things to be able to help eliminate the false positives and improve the signal to noise ratio. And we're right on the cutting edge of that as well. So anomaly detection, very easy to implement, very big potential savings for your organization if you do pay attention to it. And we'll talk about one of the important things for anomaly detection we'll talk about in a moment. And then we get to next gen, move to next gen. So effort here's medium, risk is medium, potential savings 5 to 10% maybe, probably understating a little bit in this case. I was talking with some of our folks, right? And we see from that move to next gen, the fact that you're moving from a latest generation resource to something, you're moving to latest generation resource, which is going to be cheaper and more powerful than the existing resource, right? So Amazon, Azure, all these companies, cloud service providers do submit and send out notifications as these things come out. You do want to pay attention to them. You do want to really look at them. Example here, right? So AWS, a lot of folks, real common use is AWS T3 server. Just a quick example on that. So T3 extra large runs at like 40 cents per hour. If you move to a T4G, it runs about 32 cents an hour. So it's roughly 20% cheaper for making that change to it. You also are going to end up in a scenario that is you're going to save the planet, so to speak, you're going to reduce the electrical usage by about 60% compared to that previous generation T3, which translates into a carbon reduction, which I know our company is very passionate about that. So if that's important to you and reducing carbon footprint, moving to the latest generation processors really do reduce the energy. But so you're reducing energy, you're getting a faster performing server. So upwards in this case, the per AWS, the T4G over the T3s is about 40% higher performance, 20% cheaper. What's not to love about that, right? So it's a great thing to do. The downside is a lot of these things may require you to do a fair amount of testing, right? Especially as you're changing processors. So you may not be going from an Intel to Intel, as an example, going from a Intel into a AWS Graviton processor, company specific. So you do have to test to make sure that you don't have issues with it and that your software is compatible. But it's can be a pretty significant savings from a performance perspective, because you're going to get that increased performance as well as savings in cost. So it's something you want to try to stay current on as much as possible. Everybody in the cloud to date has been, from a cloud service provider perspective, has been basically adopting this philosophy. You move to the next generation, it's cheaper and more powerful, and that's almost without exception. So moving to the next gen, very important to keep current on your technology and make those things. It's not just a set and forget. Now, moving to cloud native, that's kind of the next, the next frontier, right? If you're running a lot of legacy types of applications that you guys have built, moving to cloud native is really an interesting opportunity, right? It's high effort, high risk, the savings potential is high. Now, I was sharing this with one of our cloud Envisor consultants, and he goes, Keith, you just pitched that and you made it sound really scary, and it shouldn't be. But it is a big initiative. I don't want to mean to scare people away, but if you re-architect for the cloud, there's different schools of thoughts, right? Some people like to embrace containers versus using some of the things like AWS Lambda functions because they are cloud specific. Containers gives you, end up being agnostic from the cloud provider, which may be important to your company. But the concept is if you migrate and move to cloud native architectures, a lot of what we just talked about goes away. You no longer need to really be concerned about right sizing as much. You no longer need to be concerned about being on the latest generation technology because the cloud service provider takes care of that. And you now are just pretty much paying for a function to complete as opposed to paying for and managing servers. So it's a really powerful opportunity. And again, a lot of folks may want to go more towards a container type of a scenario, so that they have that they're cloud agnostic. Other folks double down and commit to a cloud provider and get everything they can out of it. As mentioned earlier, there's kind of baby steps you can take here as well. So whether it's using, if you're running SQL on a VM in the cloud, moving to Azure SQL database is a nice step that gives you a lot of advantages. But this is something that hopefully everybody's looking at, some path towards moving to later and greater architectures that are cloud native. That just again, the flexibility is from a business perspective, from a management perspective, it's so much easier once you're in that cloud native. And again, a lot of what we just talked about just is you don't even have to worry about it anymore. So. All right. We promised 7 ways to reduce your cloud costs. We have a 8th bonus round, which is it's really an enabling type of thing. So, Steve, do you tag? Been meaning to, yes, I'm always curious about that. It might be a personal question, but you mind answering that? Do you tag?
Yes, Keith, we do tag internally. And tagging really is very useful, especially if you don't have a highly centralized kind of management of your cloud environment. So let's say you have an engineering department that periodically spins up machines for development purposes. Tagging enables us at the management level to get a quick view of what those machines are out there. It's a lot easier to see a machine, say, that's tagged for the engineering department as, say, like a compile build workload. It's much easier to interpret those tags than to see a machine that's called something like ASB 35689 and
Right.
try to make sense of what that machine is. So resource tagging is really useful just from an overall kind of understanding of what's running in your own environments, and because resource tags can be customized, for your organization, it makes it very valuable just to be able to get a handle on your own environment, especially as the number of resources increases in terms of your cloud usage.
Yeah, I think I would say that almost any organization can benefit from a tagging methodology and strategy to help them better identify and manage their resources. But if you get to a point where you have 50 engineers or I don't even know what the nut break point is, but you get to a point where you have a fair number of engineers, tagging becomes 100% essential. And if you're a larger company that has multiple departments, tagging really helps clarify who the owner is of this, helps you understand what department that resource should be allocated to from a cost perspective. And as we talked about earlier with the anomaly detection, if you get alerted to an anomaly and you can't find out who owns that resource, you can't find the person who spun it up, you can't figure that out, you may need to let that thing run until you do. And so being able to identify very quickly who's the owner of that resource is essential. Being able to leverage tagging from a cost allocation, it's just foundational. So we highly recommend that you tag your resources. And if you're not familiar with it, tagging is at the cloud resource level, being able to put in a key value pair. You can customize them, you can use whatever you want. We do, for our tooling, have some recommendations that allows you to have some nice reporting on the back end of that, be able to have certain structures. But tagging is absolutely essential. If you don't have a tagging structure in place and strategy, highly recommend that you guys consider looking at that. And with that said, I'm going to move towards kind of recapping here a little bit on this. So we talked about various classes of these things, right? So from an optimization perspective, where do you want to focus? We always recommend focusing in where the biggest bang for the buck is. In our company's opinion, virtually everybody we talk to that's in this industry, the number one thing that you can do is that rate optimization and financial engineering. That's looking at how do I embrace the discounts. Now, some people will come back and say, you know what? Well, what about right sizing, waste reduction, eliminating all the stuff that you talked about? What if I have a lot of waste in my system? If I haven't been good on cloud hygiene, I don't want to put a cloud savings. I don't want to sign up for a 1-year commitment on something if I know I'm going to clean up a lot of stuff. So there's a couple schools of thoughts here. One is, again, as I mentioned earlier, consider layering those types of savings plans, discount programs in place so you don't overcommit. But conversely, a lot of these things, waste reduction, right sizing, next gen adoption, often take more time than you may think. And so being able to at least capitalize on that rate optimization, capitalize on those discount programs really will help you start to save money immediately. Even if you do nothing else, you're going to start saving some money. So, but again, consider layering. Don't necessarily go for 100% coverage or 80% coverage. Consider something lower than that, and then continue the other activities. And so it's also, the easiest thing to do is typically that commit to those rates. Typically, other things involve more people. They take longer to kind of implement. So that's just kind of our philosophy on this and kind of thoughts. So some of the common challenges here, right? So maybe a little bit redundant, but I think it's important to note, right? So some of the common challenges: discount programs have steep learning curves. You're making a purchase commitment for 1 or 3 years. You do need to make sure that you come up to speed on the nuance of those things, because we've heard countless stories of folks that have made a commitment, bought a reservation, and then found out they bought it for the wrong class of product and a wrong class of cloud resource, and now they basically own that thing. So you want to make sure that you come up to speed on the various aspects from a flexibility perspective. Each one's going to be slightly nuanced. As I mentioned, Azure and Azure and AWS both have very similar ways that you apply those. You also need to make sure if you have multiple cloud accounts, you're buying them in the right level of the cloud account. Otherwise, they're not going to apply across your cloud. in Google, it's a little bit nuanced because it is this project type structure. And again, you need to make sure you're buying those discount programs in the right area. Otherwise, they won't be shared. And you do want to make sure that these things can be shared across your organization. Another key challenge, we didn't get into really the whole details of that curve files. I talked briefly about it, but visibility, cloud billing is complex, and the details without some sort of tooling is very difficult to make head or tails out of it. And whether you use the cloud native tooling, all of the cloud providers have some basic tooling to help you understand it, or third party. I think they can be tremendously helpful for you guys to better understand that. And then there's the competing priorities, and so this is where this kind of goes back to that embracing the discount programs early and take them on, because typically a lot of the other things will involve a lot of people that you may not have control over if you're trying to optimize your cloud spend. So competing priorities is a big one. You may say, absolutely the most important thing for us to do right now is right size all these systems. You get on the phone with the engineer that owns them, and they're like, I'm building a new product that's about to release next week. I don't have time to look at that. So this, again, thinking about those discount programs and making those number one, to me, is a huge thing from this perspective. Okay, so creating your plan of attack. And so this focus on the biggest payback activities, right? That's really look at those things, balance the effort with the risk. Start looking at where can I invest the least amount of effort and the least amount of risk and get the highest payback. So focus on those things. I also like to start small but get started, right? So this is the old when's the best time to plant a tree scenario, and that was yesterday. When's the next best time? That's today, right? So get started on these things, because the cloud spend is insidious, right? You start racking up. Every hour that goes by is a billable hour from a cloud perspective. So as you're not making a decision, your cloud spend continues to accrue, and that bill's coming whether you want it to or not. Last on this is really leverage tooling, right? So there's cloud server, the cloud service providers all have tooling. There's third-party tools. There's analysis companies that will offer analysis to help you out. And guess what? We happen to be one of those companies. So we're here to help, right? So if you guys don't know where to get started, need help getting started, we're happy to do a quick call with you. Bring one of our cloud advisors. It's just my little plan words, right? We'll bring one of our cloud advisors into the call. Believe it or not, in a 30-minute call, we can pretty much assess and help come back with a pretty good understanding of how much money you can save and how much effort that's going to be in 30 minutes. So we'd love to talk to you more about that. If not, I'm going to kind of turn this over to Steve at this point in time.
All right, thanks, Keith. And I'm just going to talk a little bit about Envisor here for a moment, and then we have a few questions that came in that I'm just going to run by you, Keith. But first of all, just a quick bit about Envisor. So Envisor is the brainchild of Centurus, which is a BI and analytics company that's been around for over 20 years. And our team are obsessed with data optimization. And like all of you on the call, we moved our business to the cloud over the last several years. And as we shared earlier, I got a big surprise when we got a giant cloud bill a few years ago. When we looked into the covers, we discovered that the key to sorting all that out really is data and analytics, which is not only at the heart of cloud optimization, but also the heart of what was near and dear to us as a company already. So we founded Envisor to help address this problem. And today we help companies optimize the business value of the cloud through analytics. As Keith said, we're happy to speak with you about your own cloud environments and help you implement some of these options that we've discussed today. So before we wrap up, just a few more questions that came in, Keith. I'm just going to kind of throw these out to you. We have some other team members on the line here too, so anybody can feel free to jump in if appropriate. One of the questions that came up is about the percentage discounts and the reserved instances versus savings plans. That those seem to be oriented towards compute resources, basically like virtual machines. And do those apply to serverless services also, or are there other options for that, Keith? I don't know if you can speak to
that. Absolutely. So they do apply to serverless options. Most of them are compute oriented, but they do apply to serverless options. So not just EC2. And yeah, so so you can absolutely cover things such as Fargate and Lambda and all other types of things. So you do have that option with them. Um, I'd have to go back and check. I mean, there's a concept within AWS of it, just a compute savings plan that'll cover a lot of the service options. So absolutely.
Great. We also had a question about being able to tell whether instances, like which instances are under which plan, if you happen to have multiple plans in place. And so I kicked that over to our VP of services. I had a little private chat here because I wasn't sure about the answer. And what I learned is that because of the way reservations are spread across your running instances, it's not really that an instance is necessarily always tied to a particular plan. And so the best way to figure out which instances are being applied to which plans you have is really to leverage some of the reporting and tools that are available. And each vendor does provide reporting that lets you see the kind of reservation coverage of the resources that you're using.
Yeah, we didn't
And
get into
okay,
some of the key metrics here today, but I mean that's a great point, right? It's the and I'll touch on two things on this. So one, um, there are certainly rules behind the scenes as far as how the Amazon how AWS and Azure will then tag a resource as specifically in the billing files as the fact that it was covered. However, it seems to be pretty arbitrary, right? So there's no one for one. You don't reserve a specific instance. You reserved an instance type, and that may be covered or may not be covered. The best way, as you talked about, is the reporting and looking at the concepts of utilization and coverage rates. And again, we didn't get into the details of that today, but that's an important nuance that as you start looking at that is doing that. So you are buying your purchase, you're making a commitment to either spend in the case of a savings plan or commitment to use a certain type of resource when you make a reserved instance. But a reserved instance is not a one-to-one. I don't have a server named Keith out there that I buy a reserved instance for that. I buy a reserved instance for the fact that that server named Keith is a T4G. I buy a T4G reservation for it, and that will cover it, assuming I don't have a bunch of other resources running. So, but where you're doing it at scale, you're really concerned about coverage and utilization of those savings plans and reservations. And
great, thanks, Keith. And then last but not least, we have a question about being very early in cloud adoption. And do we have any kind of recommendations in terms of pitfalls to look out for in cloud costs? And I know for me, I would say the first recommendation would be going back to one of Keith's earlier slides, starting small. So the one thing you'll find when you go to the cloud is you think you're paying X dollars an hour for a particular machine, which you are. But there also are other costs layered in there, and there are storage costs and network bandwidth costs. And so going whole hog right at the beginning is probably not the best idea. Starting small and figuring out what you actually need and understanding what the real costs are. And Keith, you may have some other things to say on that topic.
yeah, I'll bring one other thing is, and we've run into this with a couple of companies that have started just recently adopted the cloud, and then they're like, oh, well, I expected my cloud bill to be, $1,000 per month, and it was $5,000 per month. What's the deal? A lot of times we'll find out that things weren't configured properly. So the challenge is though, you get your cloud bill, and again, it's a lot like looking at that credit card bill and trying to figure out what happened. You see a charge for again that restaurant, and you can't figure out what did I have that day. Same thing kind of happens. There's no resolution in the standard cloud invoice, and so embracing the cloud native tools and drilling into it, or enlisting a third party to help you get to it. But one of the core things is if you price something out and you expected it to be a certain cost and it's 10x that or 5x that, you need to drill into the bottom of that. It is a bit like signing up for cable or buying a cell phone where the price, as you mentioned, Steve, you buy the server and the price is $1 per hour, but there's all these kind of these taxes and service fees on it, like data transfer and IP addresses and all these other things that get tacked on. those things do add up, but they're typically, um, I don't want to trivialize this, but they're kind of a rounding error in the scheme of things, right? Usually the cost drivers are going to be that major resource level, the storage, the VM itself. So drilling into those and focusing in where the big hits are really makes sense. But it's again just you got to get the resolution, and looking at the bills itself, the invoice is not going to be helpful.
Yeah, one other thing that occurs to me, Keith, that we found in our own environments is that it's easy when you jump to the cloud to oversize your machines. And so we found that we had some machines that really, I would say, were supersized for the actual level of utilization. And so that's just one thing to watch out for is, don't choose a giant instance size because you think you need that much CPU. You're probably better off starting with a smaller, less expensive instance and then scaling it up if you find that it isn't enough compute for your needs, rather than inadvertently running a bunch of compute that you don't actually ever utilize.
That's a great point. Yeah, that's a great point. I mean, that's what the beauty of the cloud is that you can adjust the sizing. But what we often see, and just reiterating what you just said, what we often see is people jump to something and it's like I size a server for something that I know is not going to be a problem. And then I forget about it. And so I guess the advice there is don't forget about it or start small and increase if you have performance issues. So, but just don't ignore it. Don't do a set and forget, or you will be surprised when you open that bill.
Yep. All right. Well, we're past the top of the hour, so I think we should wrap up here. But thank you, Keith, for presenting today, and thank you, everyone, for attending. You can reach us here at Envisor. Either you can find us on the web at envisor.io, send us a note at info@envisor.io. Our own Scott Felton has been posting in the chat, you may have noticed. You can reach out to him, get some time on his calendar if you'd like to talk a bit more about your cloud costs and how you might work on optimizing those. And with that, I think we'll call it a wrap. Thank you, everyone, and have a great rest of the day.
Thank you all. And thank you, Steve, for hosting.